Morning, good afternoon, and good evening, depending on the time zone that you're in, and welcome to this webinar on number properties. This is our second webinar on number properties. The first one was a paid one. It was conducted yesterday. This is a free webinar. Our focus on this webinar is on divisibility and remainders, and to make sure that you're well prepared for this webinar, we did send some video lessons your way, the ones on prime that gives you the right foundation to prepare for this webinar. If you've not gone through these video lessons, make sure you go through them post this webinar. They are a part of your free trial. This is a free webinar. It's quite heavily attended, and to make sure that we address the needs of the population as a whole, we ask a couple of leading questions. The first one is, when do you plan to take the test? And the second one is, what is your target GMAT score? All right, let me review the responses to the first question. With regards to when do you plan to take the test, we have the two biggest populations, which is those who have that are those who have their test right away, which is in fewer than 15 days, or those who have between 16 to 30 days. Most likely, pretty much everyone who's in this group is planning to apply in round 2. Then we have the biggest group beyond that is those who haven't taken a date as of yet. Presumably, you're looking to apply next year. And then those who have between a month to 75 days, that's about 27% of you. With regards to your target GMAT scores, what I really see is upwards of 40% of you or 43% of you aim to score a 730 or higher. And then we have the biggest group, which is those who plan to score either a 710 or a 720. About 20% of you are aiming for a score of 700 or lower. All right, thank you very much. We also have some upcoming free webinars. We actually have a free reading comprehension webinar, which is next Saturday. A lot of people think to ace GMAT RC you need to be a voracious reader. In this webinar, we talk about some key reading strategies that you can use to actually overcome that handicap if you're not a voracious reader, but rather you're a regular person like pretty much most people at e-GMAT. In this webinar, through these reading strategies, we teach you how to improve your comprehension. And once you improve your comprehension, acing GMAT reading comprehension becomes a piece of cake. Also, for those of you who need a plan to reach your target GMAT score or target Quant score, we have this free Quant workshop. Think of it as a proctored mock test plus a mini Quant study plan session. So in this, we'll give you personalized insights on where you currently are today, why you currently are at that point, and then how can you approach, let's say you are at a Q39, Q40 to get to a Q48, Q49, Q50, or a Q51. With that, let me go right into the webinar pane. Again, all of the links to these webinars, they are available with us. If you want them, we can give those links in the Q&A pod. They're also available on the e-GMAT portal. So in this webinar, we'll focus on divisibility and remainders. There's essentially 3 parts to this webinar. In the first part, I'm going to give you a brief introduction to e-GMAT. That's going to be about 15 minutes. In the second part, I'm going to go right into, or rather, Saqib Hasnain, who's the head of GMAT Quant, is going to go right into the core of this webinar, and that's going to be about 105 minutes. We're going to tackle the easiest to the most challenging questions in divisibility and remainders. We're going to start with problem-solving questions on some foundations, then go on to 600 to 700 level questions, then 700 plus questions, and then data sufficiency questions. We're going to have a separate section on that. Again, the goal is going to be that we inculcate good habits. We expose the most common mistakes that people make so that we can tell you where you're faltering, why you're faltering, and make sure that you falter less. And then towards the end, if you still have any questions, we have an open-ended Q&A session in which we address all your unanswered questions. So in addition to Saqib and I, we also have Ashutosh. Ashutosh is a GMAT Quant expert who's going to support us during this webinar, as well as Sandeep, who's a GMAT strategy expert, and he is also going to support us during this webinar. With that, let's go right to the first part of the webinar, which is an open-ended Q&A. Oh, sorry, which is an introduction to e-GMAT. What was I thinking? So I asked this question earlier, what's your target GMAT score? And upwards of 42% of you wanted to score a 730 or higher. Now, and if you look at the people who are in the 710, 720 bracket, I think it's fair to say that about 55% of you aim to score 720 or higher. So while about 55% of you aim to score that, get to that score, statistically, only 6% of the people get to that score or a higher score. And this is despite the fact that schools continue to demand higher scores. And these are median scores that were released this year by these three schools. Again, you can look at some of these stats over here. Now, a good percentage of those who actually get to a 720 or higher score use e-GMAT. Why do we say that? When you look at the stats on the two of the most popular portals, which are GMAT Club and Beat the GMAT, you're going to actually come to the same conclusion. The first stat is the number of verified reviews. Over the last 3 years, more verified reviews have been posted for e-GMAT than have been posted for any of the other prep companies. In fact, when you add the verified reviews for each of these three companies, e-GMAT still has more reviews. What are verified reviews? Verified reviews are reviews that have been verified using an official score report or a valid GMAT Club membership. When you look at the number of success stories, you're going to find something very similar. Again, more success stories mention e-GMAT than do mention any of the other prep companies. In fact, all of the other prep companies combined. And these are success stories over the last 12 months on GMAT Club Share GMAT Experience Forum. In fact, if you go back 24 months or 36 months, you're going to find a very, very similar story. So why are students more successful? I think when we asked ourselves our question and we compared our courses to courses from other prep companies, one fundamental reason stood out, which was the biggest determinant, and that was the way in which we approach your learning. So when you think about learning architectures that are predominant in the industry today, there are two fundamentally different learning architectures that exist today. The first is a book-based approach or a book-based architecture, and the second is a private tutoring-based architecture. Most of the other online courses that exist today are built around this book-based architecture. They have audiovisual lessons, they will give you quizzes, but the core architecture, the core principles on which their courses are designed are pretty much the same principles on which books are designed. When you look at e-GMAT, you're going to find that it's based a lot more on a private tutoring based architecture. It takes in the good things from the book based architecture, but the core architecture is still around that of a private tutoring. So to illustrate the differences between these two architectures, we'll talk about how do you get to that 720 or higher score. So to get to that 720 or a higher score, you need to kind of follow a certain path. You need to first figure out what is your journey towards that score going to be? How is that journey going to look like? And then you've got to figure out all the concepts that you still need to learn. Then you've got to learn how to apply those concepts and ensure that you've attained a level of mastery where you are in that top 6%. Now, as you go through the subject matter portion of this webinar, we're going to expose you to the concepts that you don't really know. We're going to expose you to the gaps in application. And as you fill those gaps, you actually will reach a level of mastery either during this webinar or post this webinar in the post-webinar materials. And think of doing that not just for divisibility and remainders, but for every topic on GMAT Quant, every topic on GMAT Verbal, and so on and so forth. So in a book-based approach, here's how we answer these questions. Let's start with the study plans. A book-based approach is all about autonomy. So when you buy a book, it doesn't give you a study plan, but you rather make your own study plan. You've got to figure out the way to reach that target GMAT score. Then once you have devised that study plan, you'd go into learning concepts. Books teach you a ton of concepts, and I mean, I think that the books are probably the most comprehensive source of learning that existed 5 years ago. But once you learn those concepts, that burden of validation, whether you've learned that concept enough, is completely on you. You decide when you move forward. You decide whether you go and revise that concept or not. Then comes the application of those concepts. Why? Because you've got to learn how to apply concepts. Now, the way people who learn using books learn application is primarily by solving questions, and they solve hundreds and hundreds of questions. Why? Because a book-based architecture is not very conducive to teaching application any other way. Then you have to figure out whether you've learned enough or you've mastered the application enough that you are among that top 6%. And this is an onus that is on you. And most book-based architectures give you a mock test to evaluate whether you've attained that level of mastery or not. But there's no other evaluation that's there prior to you learning all the concepts. Or even if it is, it's not as comprehensive. A private tutoring based architecture works slightly differently. If you work with a good private tutor, that good private tutor will first evaluate you. He or she will create a personalized study plan. That study plan would be the most efficient way in which you reach to that 720 or higher score, and it'll be a manner which you're likely to hit, where it'll have those targets that you're likely to achieve. Then a good private tutor will teach you concepts, and as you're learning concepts, he'll evaluate you on those concepts and give you feedback that is personalized. Similarly, application is one area where private tutors help the most. They'll teach you how to apply the concepts. They'll look at where you're faltering, at what aspect of application you're faltering, and give you that feedback that is personalized to you. And then they'll constantly evaluate whether you've learned enough so that you can move from one topic to the other or not. So what's the difference between these two approaches? While you're learning the same content, it's the same concepts. There are two fundamental differences. Firstly, the private tutor-based approach is much more personalized. The second reason is that the extent of application that you get in a private tutor-based approach is a lot more. Let's see, why do we say that we are built around this private tutor-based approach, whereas most of the other courses are built around that book-based architecture. Let's take an example of a student who has to go from that 600 to that 720 score. So how do you get to that 720 score? The first thing when you join an e-GMAT course is we make you decide that path to your target score, and we teach you some of the best practices around it. So let's say there are two ways to get to those 720 scores, and we make you choose one of those two ways. In reality, we expose you to over 6 ways. So let's say the path that you choose is the one which is what we call as the quant-driven study plan, where you get to a Q50, which is a pretty high score on quant, and then you really say, I need to improve my verbal to a V38. Now, when you choose this path, this is for a person who's strong in quant, and you are already making that decision based on your strengths, which increases your likelihood of success, your likelihood of actually getting to that 720. Now, how do you get to a Q50 or a V38? There are journeys over there as well, and we make you choose that path as well. So let's say to get to a Q50, you say, I'm going to excel in arithmetic, and then I'm going to do incredibly well in algebra or geometry. Similarly, on the verbal side, you choose to excel in sentence correction and do really well in critical reasoning, and then you really say, hey, if I have time left, I'm going to study reading comprehension and make sure I'm slightly above average. When you make these decisions, and we actually coach you on these decisions, you make those decisions as to where you're going to spend time, and those decisions are based on what you're good at. And when you excel in what you're good at, your likelihood of getting there increases at least 2x. Here's an example of a tool called GMAT Planner that we built that allows you to make these decisions. This is a screenshot from GMAT Planner. So when you make those decisions, your journey to that 720 is not just you studying and towards the end taking mock tests and hoping that you get to that 720 score. It is a set of milestones that you can aim towards and you can track. For algebra, for example, let's say you start with a 40 percentile as a starting level, and you really say, I've got to hit to that above average score of 79 percentile. Similarly, for arithmetic, let's say you start at 55 percentile and you choose to get to that 93 percentile. So these are the milestones that you're aiming for. If you hit those milestones, you can be very certain that you'd be able to hit that 720 score. So this is about creating that personalized study plan. Now let's look at how we approach learning concepts. Now remember, a private tutor would teach you concepts and give you feedback on your learning. Now in this webinar, we're going to focus on divisibility and remainders, and this is the divisibility and remainders module within the e-GMAT online course. What you really see over here is dedicated concept files for each of the concepts. Now I'm going to show you what is in this file, but before that, let me show you how others approach the same divisibility and remainders concept. What you see over here is another very popular course. It's by Magoosh, and in this course, what you have is just two video files over here. This time that you see over here is the time of the video, not the amount of time essentially that you spent on this. Okay. Now let's see how do our files look. Here is how you go within a concept overall, where we teach you the concept. We actually teach you how do you apply that concept, and then we make you practice on that, and we show you that application right then and there. Now when you do that, you can gauge your understanding. You can figure out how well you've learned. How does a Magoosh course take this? When you look at this, it's a lot more theoretical. There's very little interactivity. It seems an audiovisual version of a book. Now let's look at application of concepts. In the e-GMAT course, we have dedicated application files for both divisibility and remainders, in which we teach you when you see a problem, what should you do in step 1, what should you do in step 2, what should you do in step 3. We also have dedicated practice files over here for each one of these, and what you see is you get a score over here, you get a score over here, and we teach you and we evaluate you and give you feedback that's personalized to you as to how well you've learned how to apply these concepts. Then we also give you a set of official guide questions to do further practice on, to make sure you get that confidence that you've actually learned. And this is how every module is architected, where you have a set of concept files and with feedback, a set of application files, a set of practice files, and then carefully chosen official guide questions right then and there. When you look at the Magoosh offering, again, you see there's no application file. There's no feedback over here. You have one quiz towards the end, and this quiz over here is actually common to not just divisibility, but also to prime numbers, also to GCD and LCM. Again, there's no score that comes over here. The intent is not to give you feedback. Now, why is that feedback important? Because you can learn these concepts without those feedbacks, but without that feedback, but essentially you won't hit that 80 percentile ability without that feedback. You've got to make sure that you plug holes in your understanding right when you're learning. That's when you get there to the first time, you will hit that 80 percentile ability. Now let's talk about the last piece, which is evaluation of mastery. You need to make sure that when you're studying algebra or arithmetic, that right at that point, you need a tool to tell you whether you've hit that 80 percentile or 93 percentile, whatever your target is. And we've built this system of what we call as ability quizzes, in which you can take an algebra ability quiz and it'll tell you how well you're doing. And it'll also tell you where you need to focus on. It is a beautiful analytics based system. So in this case, this guy needs to focus on inequalities and functions to hit that 79 percentile ability over here. So that's kind of how you can really see that even though you're learning the same content with the approach that's very similar to a private tutor based approach, with the feedback that's personalized to you, when you go through this content, why you can be very certain that you hit that 80 percentile or 93 percentile. And if you don't hit, you'll get insights as to where you need to function or where you need to focus on. Now you can build a beautiful piece of technology. It still has to have the right content. It still has to have the right learning methodology. And who's built this learning methodology? Some of GMAT Club's top instructors have built this learning methodology. In fact, if you look at the tag e-GMAT on GMAT Club and e-GMAT Quant Expert, you're going to find two experts who probably the most followed experts on the forum. Also, these experts have more reviews per faculty than any other than experts from any other prep company do. So while only 6% of the people score 720 or higher, a good chunk of that 6% work with us. We did start our batch yesterday. Here's our batch calendar. You can really see we started with number properties 1 yesterday. This is number properties 2, which is the free webinar. And then next week we go on to word problems, then algebra. We have 2 webinars on algebra, one on geometry, and then one on PMC probability, etc. And then we end with a quant workshop. You can download our batch calendars over here. With that, I've come to the end of my introduction. If you want to connect with the former e-GMATers or students who are studying at top business schools, or stay updated with all things e-GMAT, you're welcome to connect with me on my LinkedIn. With that, I'm going to invite Saqib to start the second part of this webinar. Over to you, Saqib.
Hello everyone. Before starting off this session, can you please let me know if I'm audible or not? Kindly mark yes if you can hear me clearly. If you can hear me clearly, please mark yes. Okay, I can see that most of you can hear me. So let me end the poll and I will. Okay. Once again, welcome to the second part of the webinar in which I am going to discuss number properties. Before starting off the session, let me very quickly tell you what is the purpose of the second part of the session. In this part, basically what I'll help you do is I'll help you understand what are the key important aspects to e-GMAT Quant. I'm sure all of you understand this fact that to ace Quant, one of the most important things that you need to have is a very sound understanding of the basics. So you must have very clear understanding of the concepts. But there's another aspect which I'm going to focus on while discussing the questions on number properties, which is how to solve a question in a methodical manner, in a very structured manner. This is something which not a lot of people, students focus on, and mostly when they come across difficult questions, they face a lot of problem because they don't know how to approach it. So one of the main purposes would be to help you develop a structured approach to solve questions. Now, as far as the progression of the session is concerned, I'll start off with 5 warm-up level questions. These are basic questions just to help you understand the kind of questions that we are going to discuss and to ensure that and also to get a feedback whether you are comfortable with the concepts or not. After that, I'm going to move on to PS, where I'm going to discuss 3 questions of 600 to 650 to 700 level questions. And then I'm going to discuss 4 questions which are difficult or 700 plus level questions. After that, we are going to discuss 3 questions on data sufficiency, and then I'm going to wrap up the session. Okay. So let me talk about the warm-up section. So this section will basically be based on questions which are basic questions on divisibility and remainder. And I'm going to basically give you feedback on your understanding of your current conceptual knowledge, whether you are comfortable with these topics or not. If not, what should you go and revise, or what kind of concepts you should go and learn. And the solutions, though, they are provided, but since they are basic questions, I'm not going to provide you a very detailed discussion of the solutions. I'm just going to give you at a high level what are the things that you need to do in these questions. Okay. So what is going to happen is now you're going to see a question on your screen. Since these are basic warm-up questions, there won't be 5 options to these questions. You might have maximum 3 or 4 answer choices. I'll bring up a poll. I'll give you about a minute to solve the questions. Once you're done with it, I'm going to discuss the solution. Okay. So I hope you can see the first question, and here is the answer poll in which you can mark your answer. Those of you who are still solving, I would request you to kindly mark still solving so I know how many of you are actively participating. I would request you not to post the answer in the Q&A pod. I can see one of you is posting in the Q&A pod. Please don't do that. Once you're done with the question, please mark your answer in the answer poll that is provided. Okay, I'm going to give you another 10 seconds. Okay, I'm ending the poll now. So kindly put in your responses, those of you who haven't. Okay, I'm ending the poll. Okay, so let me broadcast the result. So about 73% of you think that the answer should be B, and I have quite a few, about 23% of you who think the answer should be A. So let me ask you a question. How do I find out whether a number is divisible by 3 or not? What is the divisibility rule of 3? Kindly put in your answer in the answer presenter's question that I've provided now. Okay, sum of digits. Yes, that's absolutely correct. So if I want to find out if a number is divisible by 3 or not, what I need to do is I need to remember this rule, which is sum of digits should be divisible by 3. Now I've been given that Z is a 3-digit number, and these 3-digit numbers are, these digits are consecutive numbers. So what I can do is I can assume the digits to be x, x plus 1 and x plus 2. Now if I add these digits x plus 1, x plus 2, I'll get 3x plus 3, which is nothing but 3 into x plus 1. Now since the sum of digit is a multiple of 3, I can see it is 3 into something. That is why we can confidently say that Z will be always divisible by 3, and hence the answer in this case will be option B. Kindly mark yes if this is perfectly clear. Okay, great. I can see it's clear to most of you. In case if you have any doubts, I would request you to post your doubt in the Q&A pod. Ashutosh who is a subject matter expert at e-GMAT, is supporting the session. And in case you have any doubt which is still not clarified, please feel free to post it in the Q&A pod. He will answer them. Okay. So now let's move to the next question, which is on similar lines. Okay, try this one. Let me clear the poll and open it. Okay. Once again, please mark still solving, those of you are trying it. Another 10 seconds, everyone. Okay, I'm ending the poll. If there's anyone else who wants to put in an answer, please do it. Okay. Okay, once again, I have a very interesting result. About 50% of the class thinks that the answer should be A, and there are quite a few who think that the answer should be C. You think that the answer, the Z cannot be, is not divisible by 4. Now, let me ask you a question first. And this is a yes and no question. So, can we apply the rule that we used in the previous question? Can we use the same rule, sum of digits, yes or no? Can we use the same rule that we used for 3? Okay, that's good. I can see most of you understand this. Please understand, everyone, those of you are marking yes, the answer is no. We cannot use the same rule. So the rule for divisibility rule for different numbers are different. Okay, so the rule that we are applying for 3 may not be is not actually valid for 4. Okay, so those of you who do not know the divisibility rule of numbers, basically 3, 4, 5 and so on, should definitely go and revise this, go through the concept file and understand what are the divisibility rule of different numbers. Now, in case of 4, what is the divisibility rule of 4? I can see one correct answer in the Q&A pod, but can you put in your answer in the answer presenter's question? How do I find out whether a number is divisible by 4 or not? Last two digits should be divisible by 4. Absolutely correct. Okay, so one of the thing is that you need to keep in mind is the number should be even. Okay, if the number is not even, then it's very easy to understand. If the number is odd, obviously that number will not be divisible by 4. That is one case. The second thing is, even if the number is even, you need to check whether the last two digits of that even number is divisible by 4 or not. Okay, now keeping this in mind that the last two digits should be divisible by 4, the one case is, since the number are consecutive, z could be odd. Now can you tell me a number where it's a 4-digit number where z could be odd? Any number? 2, 3, 4, 5. Absolutely correct, and that is the number that we have written out here. No, 1, 1, 1, 1 is not possible. Please understand, because these are consecutive numbers. So all the 4 digits cannot be the same. It's okay. Even if you, and 3, 4, 5, 6 again is not possible, because 3, 4, 5, 6 is an even number. Okay, so when you're talking about odd numbers, one of the cases that 2, 3, 4, 5 is one of the cases, and we can say, okay, in this case, it is not divisible. But when z is even, there are two possible scenarios. One of the scenario is that the last two digit may be divisible, and one of the example given in the answer presenter's question is 3, 4, 5, 6. So that is one of the cases. Okay. The second case could be where the last two digits may not be divisible, and in that case, one of the cases could be 1, 2, 3, 4. Now, when the number is 1, 2, 3, 4, in this case it is not divisible. When it is 3, 4, 5, 6, it is divisible. When z is odd, it is not divisible. So I have two cases where it is not divisible, one case where it can be divisible. So the answer would be option A, that z may be divisible by 4. Okay. Now tell me one thing, those of you who marked the answer as C, that is not divisible by 4, where exactly did you falter? Yes, you can. So now can you tell me where exactly did you falter? Why did you choose option C? Did you not consider all these cases? Okay, just applied first question rule. Okay, okay. Didn't consider. Okay, so you need to whenever you're solving questions like these, if you're not using the generalized form, it is always good to check two, three cases. It's always best to analyze from all perspectives. So when you're talking about 4, you should always look from the terms of even, odd. Even in even, you know that a number, there are a lot of numbers which are even and divisible by 4. So you should look for a case where it's possible or not. Okay, and the other purpose of giving this question was to obviously tell you this fact that you cannot apply the same divisibility rule everywhere. Okay, with this in mind, can you try this next question? Okay, another 10 seconds. I have about 65 responses. I need a few more. There are 130 people in this session. Come on, guys, please participate. It's okay if you get it wrong. Once again, I would request students not to post the answer in the Q&A pod. Please. Okay, I'm ending the poll now. Uh, uh, I don't know what happened. Can you please put in your responses once again, guys? Somehow, very quickly once again. Okay. So about 81% of you think that the answer should be C, and there are a few of you think the answer could be B or C. So let me ask you this question. What is the divisibility rule for 8? How do I know whether a number is divisible by 8 or not? Kindly put in your response in the answer presenter's question. Okay, it's not same as 4. For if you want to find out if a number is divisible by 8 or not, then what you need to do is you need to check the last 3 digits is divisible by 8 or not. So in this case, what I'm going to do is I'm just going to take the last 3 digits, which is 8, 9, and 7, and I'm going to divide this by 8. On doing so, I get the remainder as 1. Now, when I get the remainder as 1, what does that exactly mean? Why do we get a remainder? This is something which is extra or more than what is required for the number to be divisible by 8, right? So if I want to find out the number which is closest to this, what should I do with this number? What should I do? Should I add 7 to it or reduce this number by 1? Minus 1. Yes, please understand this. We are asking for a number which is closest. Okay. So there are two ways in which you could have got a number which is a multiple of 8. So if you have 1 extra, you could have added 7 more to it to make it divisible. So those of you who did that ended up marking option A, which is not the correct answer because we are looking for the closest number. So if you want to go close, instead of adding more numbers to it plus 7, it is always best to subtract 1 from it and get the closest number, which is in this case would be option C. Okay, is this clear? Yes, in this case you can consider 97 to solve it, but please understand that it will not be always that you'll get a number like this. So suppose instead of 897, if you had 797, right? So in that case you need to consider all the 3 digits. Okay, so I hope that answers your question. Though someone who's asking 800 is divisible by 8. So in this case it's okay if you just take 97. But if instead of 897 for 797, you would have to do. Okay, someone is asking why can't we add 1? Okay, even if you add 1, what will happen? You need to understand the concept of remainders. When we say I'm getting a remainder of 1, so a very simple example, take 5 divided by 2. You get a remainder of 1 because you're getting some more than what is required for the number to be divisible by 2. So you need to subtract 1 from it to go back to 4. In this case, to make the number divisible by 8, since there's a remainder of 1, that is the number contains 1 extra, you need to remove that extra, not add 1 extra to it. If you add 1 and divide by 8, you'll get the remainder as 2. That won't help, right? So I hope this answers your question. So let's move on to, let me just ask it once again. So kindly mark yes if now this is perfectly clear. Once again, if you have any doubts, Ashutosh is there to help you out. Please ask your questions in the Q&A pod. He will answer them. So I can see a few of you marking no. If that's the case, please ask your question in the Q&A pod. Okay, I want to ensure that all of you get this correct, all of you understand everything properly. Okay, now the last two questions are slightly different. So far in the first three questions we were trying to figure out the divisibility rule of a number. Okay, now this is mostly based on quotient and remainders. Let me bring up the answer choice. And here is the poll. Another 10 seconds, everyone. Okay, I'm ending the poll now. So those of you still who want to put in your polls, please do it. Okay, great. Let me broadcast the, I don't know what is happening. Can you please put in your response? I'm really sorry for this. Can you put in your response once again? Just 1 second. Okay, great. So let me broadcast the result before ending the poll. Okay, so most of you, 80% of you, which is a good thing, think the answer should be D. And that is in fact the correct answer. So let me discuss the principle behind solving this question, and especially guys, please understand this principle because most of the questions that we are going to discuss from now on will be mostly based on this. So what concept should I use in this question? I've been given a remainder 3. I've been told the number that it is being divided by, and I need to find out what is in the number when n is divided by 4. So what is the concept that you need to use to solve this question? Obviously you cannot use the divisibility rule of 3, 4 and so on, but so when a number is divided by another number, that's what I was looking for. That's good, exactly. So the concept that you need to use is dividend is equal to divisor into quotient plus remainder. So please understand the number that is being divided, n, this is the dividend, okay? The number which is being divided by is known as the divisor, which is 204 in this case. Quotient is obviously we don't know what the quotient is, but we know what the remainder is. What I need to find out is when the number is divided by 3, what is the remainder? So it is always best when you get questions like this to write down in the form of an equation what exactly do you need to find out. So in this case, I need to find out when I express n as 4 into p plus r, where 4 is the divisor, p is the quotient and r is the remainder. I need to find out the value of r. Now tell me one thing, what is the constraint on r? What is the constraint on r? Can r be 5? Can r be 7? What is the value that r can take? Less than d. Okay, that's absolutely correct. So this is one thing which you always keep in mind is that the remainder is always less than the divisor. And Jalaj, that's absolutely correct. That the remainder can be 0 also. The remainder has to be greater than equal to 0 and it should be less than the divisor. It will, so if I'm looking for the remainder when n is divided by 4, it's automatically you should understand that the remainder will be less than 4. Okay. What I've been given is that n is equal to 204q plus 3. Now what you need to do is you need to visualize, okay, this is my number. I'm going to divide this whole number by 4, or I need to express it in this form. This number in this form and see what is the remainder. So if you use the process of visualization, you'll be able to understand that, okay, 204 is automatically can be written as 4 into something. Or in short, you can say 204q is divisible by 4. It does not leave any remainder because 204q is nothing but 4 into 51q. Okay, since it can be written as 4 into something, that means this portion 204q is already divisible by 4. It won't leave any remainder. So what is left? We are left with 3. Now this 3 is already less than 4, so obviously we cannot, the remainder would be 3 in this case also. So 204q will be written as 4 into 51q and this 3 will be left as is. We can say this portion is divisible by 4, so I won't get any remainder. When 3 is divided by 4, the remainder would be 3 itself. Hence the answer in this case would be option D. Now tell me everyone, is this, let me bring up the yes and no poll. Is this perfectly clear, guys? Let me clear it once. Is this clear? Please understand, you need to understand this concept of Q into D plus R, because most of the questions that we are going to discuss will be based on this. Yes, that's correct. 204 is divisible by 4. So obviously the remainder 204 into something. So Paulo, you need to keep this in mind is that it is 204 into something. So you need to make that conclusion that 204 into something will always be divisible by 4 since 204 is divisible by 4, and that is a decent approach because you won't get any remainder from here. So what you're left with is 3, and hence that will be the remainder. Okay. So I can see about 9 of you are still saying no. So if there are any questions, please ask. Okay, somebody is asking why is P 51? Okay, divide 204 by 4. What will you get? If you divide 200 by 4, what will you get? Won't you get 51? That is why I'm writing 204 as 4 into 51. The reason I'm writing this is because see, I need to express 204q plus 3 in this form, 4p plus r. Why am I expressing in this form? Because I'm dividing it by 4. That is why I'm taking this portion 204q and dividing it by 4 and seeing whether it is divisible or not. If it is divisible, then there's no problem. I can automatically conclude the remainder will be 0. Okay, somebody is asking what. So see, there can be hypothetical scenarios. If you say what if n is 0 by 205, then in that case I'll say we cannot find out the answer, Rachit, because I don't know the value of q. So Rachit, and GMAT won't test you in a question like this, because then the answer would be cannot be determined. I cannot find the answer. I hope that answers your question, Rachit. So 200, if I'm given 205, I know 3 divided by 205 will give me 3, but I don't know what will happen with 204 into q since I don't know the value of q. So in that case, the answer would be cannot be determined because I don't know the value of q. But please keep in mind, GMAT will not test you in questions like this. Okay. So if this is clear, let's try a similar question, which is this. Once again, guys, if there are any more questions, please ask in the Q&A pod. Ashutosh will answer them. Let me bring up the poll, just one sec. Okay, this should be easy enough to solve, so I'm giving another 10 seconds. It's based almost on the same logic that we solved for Q4. Okay, I'm ending the poll now. Okay, so this time it's a fairly good response. 71% of you think the answer is A, and I did expect a few of you to mark the answer as D, which has happened. 24% of you think the answer should be D. Now, those of you who mark D, this question is especially for them only. Okay, those of you who mark A don't answer. What is the divisor in this case? Put in your answer in the answer presenter's question. What is the divisor then? It's okay. Those of you who got it incorrect, I want to know. The divisor is 5, right? Now tell me, if the divisor is 5, can the remainder be 6? Can the remainder be more than the divisor? No, right? So when you were marking 6, you should have questioned yourself. It's very important. That is why I was emphasizing in the previous question about the remainder. Everything in this remains the same. So in this case also I need to find out, express n in the form of 5p plus r, where r is less than 5. Always write down these things in paper so that you never ever forget and mark the wrong answer. You are given n is equal to 205q plus 6. Now as expected, all of you must have understood that 205q is divisible by 5 since it can be written as 5 into 41q. So this was easy. So what is left? You are left with 6. So leftover is 6. But now you need to question yourself. Can R be 6? It cannot be because I have a constraint. The constraint is r should be less than 5. So whenever you come across a scenario where the remainder is still more than the divisor, you need to divide it again. Okay, so you need to divide 6 again by 5 and see what is the remainder. So 6 when divided by 5 gives a remainder of 1. Hence the answer in this case would be option A. Is this clear, everyone? Let me bring up the yes and no poll once very quickly. Okay, kindly mark yes if this is perfectly clear. So these are small takeaways that you need to keep in mind, that okay, whenever I'm solving a question which is related to remainders and quotient, I need to use this concept, dividend is equal to divisor into quotient plus remainder, that is point 1. Whenever I'm trying to find out the remainder, I need to apply the constraint and keep this in mind that the remainder will always be less than the divisor. If I'm not getting that, I need to divide it again, or I'm making some mistakes, so I need to look at the solution that I've written down. So these are two takeaways that you need to keep in mind. So with this, guys, again, the main thing is make sure that you have 200 clarity in concepts. If either of the concepts are still not clear, please go back, revise the concepts. We have shared with you the free concept files. Okay, if you're scoring less than 100, then as I told you, you need to go through the concepts. And believe me, GMAT will not going to test you on really hi-fi concepts. The concepts are going to remain really simple. That is Q into D plus R. That's it. All the advanced level questions are just based on the small logic, nothing else. Okay. Keeping this in mind, let's start off with 657 level questions. Now, since these are more GMAT-like questions, in all these questions you'll have 5 options. Okay. Let me end the poll. And these are based on all the same concepts that we have discussed so far. Okay, please mark still solving. Another 10 seconds, everyone. Try to use the same concept that I've taught you. There's just one minor difference here, nothing else. Okay, I'm ending the poll now. So if there's anyone who wants to put in your vote, please do it. Okay, fine. Okay, so far I have a mixed response. About 58% or 58.7% of you think the answer should be C. I have a few B's and C's, around 14% of you think the answer should be B, some of you think the answer should be A. Well, this is a very good question, and I would answer again in this case is C. But there are a lot of learnings from this question which you need to, which I want to discuss with you all. First thing first, we discussed in the previous 5 questions that the remainder is always less than the divisor. But there's one more thing which I did not discuss is, uh, can the remainder be a decimal number? Yes or no? Can the remainder be decimal? Like 0.2, 0.5, 0.7, 0.8? No, right? The remainder is always an integer. Okay, please keep this in mind, that the remainder is always an integer. Again, I'll take a very simple example to explain you, which is again 5 by 2. So when a number 5 is divided by 2, there are two ways to express the result. One is to simply write 5 by 2 as 2.5. Okay, in that case I can say 5 divided by 2 is 2.5, that's it, done. The other way to say is, when 5 is divided by 2, the quotient is 2 and the remainder is 1. Okay, because 2 into 2 is 4 plus 1. That is the way of saying it. So keep this in mind, whenever you are expressing this in this form, you are simply dividing it. M was simply divided by 30 and everything was expressed in the form of a decimal. Now the next question is that why are we getting this decimal 0.2? The reason we are getting this decimal is because of the remainder. Now if I'm dividing 4 by 2, I simply write it as an integer, right? 4 by 2 is 2. Why? Why is there no decimal point? Because it is completely divisible. But when I'm dividing 5 by 2, I'm getting that 0.5, 2.5. The 0.5 is because now I'm expressing the remainder in the form of a decimal, which is 1 by 2 is 0.5. So I'm writing it as 0.5. Okay. Is this part clear, everyone? Kindly mark yes if it is. Have reopened the poll. Is this part clear? The 0.2, we are getting this 0.2 because that number is not, M is not completely divisible by 30. If M was completely divisible by 30, I would have got an integer, something like an 8 or something like that, or a 9 or a 10. So while looking at the option, the first thing we should have done is eliminated this option. This cannot be my answer. So 13% of you marked the answer as A. I hope now this is perfectly clear why the answer cannot be A. Because I'm getting a 0.2, I'm getting a decimal after the integer. That means it's not completely divisible. Point number one. Number two, since the remainder cannot be a decimal number, our answer can never be 0.2 or 8.2. The answer has to be either 6 or 14. Okay. Now one way is, as Sandeep has written, what you can simply do is you can simply multiply m is equal, you can write m as 30 into 8.2 and find out the value. Okay, do the full multiplication and then divide by 15. That is one way of doing it. However, I want to make it more, I don't want to do the calculation. I'm not interested in doing the whole calculation. So I'm just using my conceptual knowledge. I just told you that this 0.2 is because of the remainder, right? So if I split 8.2 and write it as 8 plus 0.2, can I write 30 into 8.2 like this? Kindly mark yes if this step is clear. What I'm doing is I'm splitting 8.2 as 8 plus 0.2 and I'm multiplying it by 30. Why am I doing this? I'm doing this because I know this part is obviously fully divisible. This is the part from where I'm getting the remainder. Now I know I need to find out when m is divided by 13. So see, I'm not doing any multiplication. I'm just doing some manipulation of the expression. Once I get this, I need to find out what is the remainder when m is divided by 15. So this portion, 13 to 8, this is divisible by 15, right? Because 30 into 8 can be written as 15 into something, 2 into 8. Now if it's 15 into something, then that means this is fully divisible. What am I left with? 13 to 0.2. 13 to 0.2 is 6 and 6 is already less than 15. Hence the remainder in this case would be option C. So it's perfectly fine for those of you who want to do the full multiplication, 30 into 8.2, find out the value and then divide it by 15, that's fine. But the best way, a better way is to try and avoid as much calculation as possible. So to avoid the calculation is to make sure that your conceptual knowledge is clear. Okay, 30 into 0.2 is a number. How much is 30 into 0.2? Tell me, when you multiply it, what do you get? Somebody is asking 30 into 0.2 is divisible by 15. How much is 30 into 0.2? I just told you the remainder is an integer. Please keep this in mind. So 30 into 0.2 cannot be my remainder. Cannot be fully divisible by 15. I'm sorry. 30 into 0.2 cannot be divisible by 15 because 30 into 0.2 is 6. So you need to find that and then decide whether that number is divisible by, it can be the remainder or not. Okay, so I hope that answers your question. So don't go blindly and assume, okay, 30 is divisible by 15, so the answer is 0. Don't do that. Keep these two constraints in mind. Remainder should be an integer remainder should be less than the divisor. So 30 into 0.2 cannot be my answer. Cannot be divisible by 15 because this is still in the decimal form. I need to multiply, get the value. Okay. So the last step is very simple. See, you split it into two halves. Why I'm doing this? Again, I'm telling you, I'm splitting it because this 0.2 is the main culprit because of which I'm getting the remainder. So I split it. After splitting it, I need to find out what is the remainder when m is divisible by 15. Now 30 into 8 is divisible by 15. I can very clearly see that because 30 into 8 can be written like this. Once I multiply this, I need to multiply this because I need to check the integer part and then take a call. On multiplying 30 into 0.2, I get 6. 6 is less than 15, hence that will be my answer because this portion is already divisible. This part 15 into 0.2, it is already divisible. Okay? Okay, with that, let's move on to the next question. This is almost similar to the previous one. So if there's still any more doubts, once again guys, please ask in the Q&A pod. Ashutosh will take care of your queries. However, if it's perfectly clear, you should be able to get this answer correct. Okay, another 10 seconds. I have most of my responses, but I'll give you another 10 seconds. Okay, I'm ending the poll now. So the good thing is, as you can all can see that 94% of you think that the answer is option C, which is definitely the correct answer. So it's a good thing that you have understood the concept of the way of solving it. Before going to this, I can see one of you say that I think multiplication is faster in the answer presenter's question. So let me make this very clear. Yes, you can use both the methods. It's totally on you what you're comfortable with. So in this question also, you are more than welcome to multiply 15 into 8.2, find out the value and divide by 30. That's absolutely okay to do it if you want to do it. But to solve, the reason why I'm teaching this method is because it is very easy to just simply manipulate and write 15 into 8.2 again and split it like this. See, and this can be done even mentally. You can think about it like this: 15 into 8 plus 15 into 0.2. So 15 into 8 when divided by 30 will obviously be divisible, right? Because I can write this as 30 into 4. And what I'm left with is 15 into 0.2. 15 into 0.2 gives 3. 3 is already less than 30. Hence the answer in this case would be option C. Okay. So those of you who are still marking the answer as B and A, I would request you to please tell me where exactly are you making a mistake? What went wrong? What did you not understand? I did very clearly tell you that the answer cannot be a decimal number. So you should have already removed these two options. I did also tell you when m is divided by a number and you're getting a value which is in a decimal, this also clearly indicates that the answer cannot be 0, the remainder cannot be 0. So you need to move on like this. Okay, that's a good question. And my next question is based on this rule only. So I can see a question in this Q&A pod. What if it is not divisible by 30? So my next question is based on that only, which I want you all to try. And tell me what will be the answer. Okay, another 10 seconds, everyone. Okay, I'm ending the poll now. Okay, let me share the result. So I have a clear split. Obviously, the majority thinks the answer should be E, but I have a few of you who think the answer should be B. Okay, and this question was specifically created just to test whether you are solving the question using correct logic or you are just blindly solving it. So the answer in this case obviously is E. And I'm sure by now you must have understood to write these things. When m is divisible by 3, I need to find out this 30. So I need to find out, express m as 30p plus r, where r is less than 30. So these are my basic constraints. What I'm given is 15 into 9.2. Now, some of you might go blindly and simply write 15 into 9 plus 15 into 0.2 and simply solve this part and say the answer is 3. Okay. Now, let me ask this question. How many of you did that? I'm sure those of you marked B, especially I'm asking those, did you do this? You simply found this value and said the answer is B. Okay. But please understand, what did I tell you? We are just, we focused only on the second part, only and only when the first part is fully divisible by 30. Now tell me, 15 into 9, is this divisible by 30? 15 into 9? No, right? Because 50, when I divide this by 30, I would get 9 by 2. So what you need to do is, obviously one way is to multiply it. Somebody did that, 15 into 9 and then divide by 30. That is one way. The other way to look at it is, I need to make it multiple of 30. So let me split 9 and write it 8 plus 1. The reason I'm writing it as 8 plus 1 is because 15 into 8 is divisible by 30. 15 into 8 is divisible by 30. So what I'm left with is 15 into 1 plus 3. So now I can say 15 into 8 is nothing but 15 into 2 into 4. Now this is 30 into 4. So now I have this and this 30p is taken care of. So whatever now that is left will be my remainder. So now when I multiply it, I get 18, and 18 is less than 30. Hence the answer in this case would be option E. So is this clear, guys? Kindly mark yes if this is clear. Please understand, in most of the cases, you will get questions where you just need to focus on this, but you only focus on this part is when this is divisible. And again, I'll tell it very clearly. If you're comfortable multiplying, please do it. It's totally okay. But the reason why I'm telling you these methods is because when you are dealing with variables, when you're dealing with data sufficiency questions, there will be scenarios where you won't have exact numbers to deal with. In those cases, it will be important for you to know these manipulations. If you don't know these manipulations, you simply multiply. In data sufficiency questions, you'll falter. Okay? With this, as I told you, see, we were using the same concept. Dividend is equal to divisor into quotient, and we solved 3 questions which are progressively increasing difficulty level. In the first question, second question, we were just focusing on the second part, right? In the third question, we saw how we can use manipulation to solve the question. So see, the concept, as I told you, in GMAT will remain the same. They might make it difficult by involving a few more manipulations. Now with that, let me come to this second part of the PS question, where we are going to discuss 700 plus level questions. But before doing that, let me ask you this. I hope now, from the result, it's quite evident that most of you are comfortable with the concept. So let me now talk something about a slightly different concept now. So what I'm going to do is I'm going to talk about remainders only, but now I'm going to talk more from the point of view of expression, when we are dividing an expression by a particular number. So take this question for example. It's a very easy question, and I'm taking easy numbers so that it is understandable by everyone. So what will be the answer in this case? You can put in an answer in the answer presenter's question. When for 31 plus 43 is divided by 7, what is the answer? It's easy, right? The answer is 4. It's a very easy question. Now you might be wondering, why am I asking this? The reason I'm asking this is because there are 2 ways to solve this question. Whenever you have an addition sign, the one thing which you can do is you can simply add the numbers, 31 plus 43, get 74 and divide by 7. The other way to do it is, Divide each number 31 and 43 by 7. Okay. Find out the remainder of 31 by 7 and 43 by 7 and then add that up to get the remainder. Now, which one did you all use? The first one or the second one? Sequence 1 or sequence 2? Okay. See, keep this in mind. It's totally okay. You can use I in this. In case of addition, it's totally okay. You can use 1 also, 2 also, depending on the type of number that you have. If you have really big numbers, you can simply divide them individually. In case of this, like it's very easy to add 31, 43, 74. You can use the first method. However, that's a very good question. What if the number exceeds 7? Now, there could be a scenario where on adding these two, on adding 3, in this case it's 3 plus 1, but there could be a scenario where you could have got 3 plus 5. Okay, that's quite possible. So instead of 43, if you had for say 47 by 4, you would have got a number after adding which is greater than 7. What will you do in that case? If after adding up, say if you got 8, suppose you got 8 after adding, what will you do? Again divide by 7. See, the funda is very simple. The concept is the remainder should be less than the divisor. What is the divisor in this case? It's 7. So if on adding these two remainders, I get a number which is greater than 7, say 8 or 9, I'll divide that by 7 again to get my final remainder. Okay, that's it, nothing else. Now instead of addition sign, if I had a multiplication sign, what will be the answer in this case, everyone? What will be the answer if instead of plus, if it was a multiplication sign, what will you do? What will be the answer? Yes, it's 3. The answer in this case would be 3. Now again there are two ways. One is you multiply both the numbers, 31 into 43, get 1333 by 7 and find the remainder. The other way is to find the individual remainder and multiply it. Now what do you think is a better method, the first one or the second one? The second one, right? So in this case, keep in mind whenever there's a multiplication sign, it's always good to simply use the second method. So multiplication sign, in that you find out the value and then individual values and then simply multiply them. In this case also, even after multiplication, if there's a scenario where you get a value, say instead of 3 into 1, if it was 3 into say 4, you would have got 12, right? So if you get 12, divide again by 7. That's it. The concept remains the same. Okay. Now the reason I'm teaching this is because the next question that is going to come on your screen is based on this fundamental principle. Okay. So whatever I've taught you here, try to apply the same in this question. I'll bring up the poll in 1 second. Okay, so here comes your poll. Just use the same understanding and solve it. Okay, another 10 seconds, everyone. Okay, I'm ending the poll now. I have a very interesting result, and every time I take this session, I get a response something like this only. 55% of you think the answer should be A, and I have about 38% of you think the answer should be B. Now, those of you specifically who selected the answer as C, okay, tell me, what did you do? What is the remainder? Okay, let me ask you this question. What is the remainder when 24 is divided by 3? 24 divided by 3, what is the remainder? 0, right? That's absolutely clear. 24 is divisible. What about 38 when 38 is divided by 3? 2, right? What is the sign in between? Is it an addition sign or a multiplication sign? It's a multiplication sign, guys. So don't just blindly add both the remainders and find the answer as 2. So those of you, most of you, 37% is a big number. As I told you, it happens with everyone. I teach them the concept that remains in their mind and they end up taking 0 and 2 and marking the answer as 2. But please keep this in mind. If whatever you are multiplying it with, if any one of the number, any one of them is divisible by the divisor, don't solve anything else, just mark the answer as 0. Think about it, a number which is divisible by the divisor, any multiple of that will also be divisible. So what I mean by that is, if 6 is divisible by 2, any multiple of 6, be it 12, 18, whatever that be, will always be divisible by 2. Same fundamental principle applies here. If 24 is divisible by 3, any multiple of 24, how many times do I write it does not matter. So in this case, the power will not matter at all. Even if it is 24 to the power 3000 or 38 to the power 5000, does not matter. The answer will be 0 because it's a multiple of 24. And yes, we don't need to check. So somebody is asking, do we really need to check for 38? No, it does not. The reason I was asking you this question was because I know where you ended up making the mistake. So in this case, as I told you, once you figure out that one of them is divisible, that's enough for you to conclude that the remainder will be 0. You don't need to do anything else. Yes, it is easy, but see, even if this was easy, 38% of you ended up making a mistake. And e-GMAT knows that people end up doing this, and whenever you are in a situation, when you're taking an exam, you are mostly in a pressure. So sometimes what happens is that you don't see a lot of things properly. You don't see simple things like multiplication and addition sign, and then you end up marking a mistake. Okay, that's it. So keeping this in mind, try out the next question, which is slightly different now. You should be able to answer this very quickly because there's only one thing that I've changed in this. But be careful while marking the answer. Again, once again, don't mark the answer blindly. Okay, I'll give another 10 seconds. Okay, I'm ending the poll now. Okay, let me broadcast the result. So good thing is now most of you are getting the answer correct. In this case, the answer is C. Those of you who ended up marking A, B, or D, let me explain it to you clearly what is the fundamental principle behind this. So those of you ended up marking A, you did not notice none of the number, neither 25 nor 38, none of them is divisible by 3. Okay, so if none of them is divisible by 3, then obviously the remainder cannot be 0. That is one conclusion that you should have made. So two of you marked the answer as A. I hope now you understand why the answer cannot be A. Now let's talk about the other options. So there's one more thing which I want you to keep in mind is that once you find out the remainder, okay, that does not itself give you the answer, especially when the remainder is not 0. So say if I'm dividing this number 25 and 38 and I know there's a power 3, this power 3 does play a role. So 25 into 38 to the power 3 means that 25 into 38 is being repeated 3 times. So obviously the easy way is to first of all find out 25 by 3. What is the remainder when 25 is divided by 3? What is the remainder when 38 is divided by 3? Find out these two things. You'll get 1 and 2 respectively. But please keep in mind, don't forget the power. Don't forget that there is no power at all. The power will play a role once you find out the remainder. Because in each of these cases, you'll get 1 into 2, 1 into 2, 1 into 2. So the remainder also 1 into 2, which is 2, will be repeated 3 times. So ultimately, whatever is there inside the bracket, once you find out the value of that, make sure that you put the power also back, find out what is the value. Okay, now in this case 2 cube gives you 8. Now this 8 is obviously not less than 3, so you need to divide 8 by 3 and then find out the remainder as 2. So those of you did not do it, those of you simply got 2 into 1 2 and found out the value, please don't do that. Please keep in mind the power also will play a role. The answer coincidentally in both the cases, even if you make a small blunder, you'll end up marking the right answer, but this is the correct way of solving the question. So somebody is asking whether a to the power 3 into b to the power 3 is equal to a into b to the power 3. Yes, it is exactly that only, Varun. Is this perfectly clear, guys? Is there any doubt? Kindly mark yes if it is perfectly clear. So someone is asking, can I forget about the exponent? So this is how I solve the question. One thing is, so Varun, there's no difference in the approach. Now look at the previous question also. Let me go back to the previous question just to tell you there's nothing different. In this case also, when you divide 24 by 3, the remainder is 0. Now tell me, how much is 0 to the power 3? How much is 0 to the power 3? Let me reopen this. 0 to the power 3 is 0, right? Now 0 into anything. Now 38 to the power 5 is 1. 1 to the power 5 will be what? 1 only. Sorry, here you are getting 2 to the power 5. Really sorry. 38 by 3 is 2. Remainder is 2. So 2 to the power 5 into 0 will give you what? 0 only. That is why I did not go into the calculations out here, because it wasn't needed, Varun. But the principle in this case, it's not that I'm ignoring the powers. I'm not considering them because I already have a 0, and 0 to the power anything, 0 to into anything will give me 0. That is why I'm not solving it. But once you get if you have a non-zero value, like in this case you have a non-zero value, you need to consider the power. The power never goes anywhere. So even when you solve 25 by 3 and 38 by 3, whatever you get, you need to consider the power later on. So the idea behind solving these questions is simple. First solve whatever is there without the power. Once you get the remainder, bring back the power. Find out that value, because now the number becomes small. So it will be easy for you to solve. That is why we are using this method, nothing else. Okay. So in this case, as you saw, what we were doing was simply using the same principle, the addition multiplication principle. Power, the thing with which I talk about the power is whenever you have a power, you can ignore the power initially, find out the value, and then bring back the power to solve the question. So that is the learning out here. Now let me talk about something which is not taught anywhere, and this is a really interesting concept. Okay. But before teaching this, let me add a few disclaimers, and I will be very clear with this. In GMAT, you will never be tested on negative remainders. Okay. In GMAT, the value of the remainder is always less than the divisor and greater than equal to 0. Okay. It's is always fixed. So whenever you're solving a question in GMAT, please keep this in mind. Whatever value you get of the remainder, that should be either 0 or a positive number less than the divisor. The reason I'm teaching you negative numbers is a negative remainder out here is because this concept, though, can help you in some ways solve a lot of questions very easily. Okay, and I'll explain this once again by taking very simple examples because it is very easy to understand. So as you can see, 5 divided by 2 gives you a remainder 1, right? And you can write 5 as 2 into 2 plus 1. Another example is when 8 is divided by 3, you get 3 into 2 plus 2. So the remainder is 2. But now let me ask you a question. So this is just an equation, right? 2 into 2 plus 1 will give you 5. But there is another way to write 5. Can I write 5 like this? 2 into 3 minus 1. Kindly mark yes or no. Can I write it like this? 2 into 3 minus 1. 2 into 3 is 6, minus 1 will give you 5. Don't take it from the term of quotient remainder now. Just I'm asking us in the form of an equation. It's possible, right? I'm dividing 5 by 2. And I need to express 5 in terms of this, so let me write it like this. Similarly, I can write 8 as 3 into 3 minus 1, right? 3 into 3 is 9, minus 1 gives me 8. Okay. Now this is where the negative remainders come into picture. So this minus 1 out here, this minus 1 out here, these are known as negative remainders. Okay. Now you might wonder, you might ask me, what is the use of this remainder? Why am I considering negative remainders? Okay. So let me first give you a background. The next question will obviously help you understand why I'm using it. But let me give you a simple background here. Now suppose instead of 8 by 3, if I would have asked you 8 to the power 50 by 3. 8 to the power 50 by 3. Okay. Now what did I tell you now? Even if there is a power, you can ignore the power and simply divide 8 by 3. If you use positive remainders, you will get 2. Okay. But once you get 2, what will you do next? Kindly type in your answer. You had 8 to the power 50 by 3. You ignored the power, you divided it by 3, you got 2. You'll add back the power, right? Now you need to think about 2 to the power 50. Now think about it in this way. Isn't it difficult to solve 2 to the power 50? Isn't it difficult? How will you find out the value of 2 to the power 50? It's difficult, right? However, think in this way. If instead of writing it 3 into 2 plus 2, if I write it as 3 into 3 minus 1, okay? If I write it as, yeah, you can break it up. You can break 2 to the power 50 and keep on solving it. That's absolutely fine. But now what I'm asking is, instead of breaking and going into that method, what if I write it as 3 into 3 minus 1? In this case, I'll say my remainder is minus 1, right? I can say my remainder is minus 1. Now if I bring back my power, now if I bring my power and write it as minus 1 to the power 50, how much will I get? Minus 1 to the power 50. It's very easy, right? Now I don't need to do anything. I know minus 1 to the power would give me 1, hence the answer would be 1. Okay? Is this part clear? That is the reason of using, that is the benefit of using a negative remainder, because now you don't need to calculate 2 to the power 50, you don't need to go into the hassles of breaking it down and solving the value. Yes, I was waiting for somebody to ask this question. So Veena asked me a question, what if it is, and Shah also is asking the question, if it is an odd power, instead of say 50, or what if I had a 49? That's a very good question. Now minus 1 to the power 49, what will you get? Minus 1 to the power 49? Minus 1, right? So, and I did tell you that GMAT does not test you on negative remainder. So how should I convert it back to a positive remainder? So to do that, that is why I have discussed what should you do when you want to convert the negative remainder back to a positive remainder. So if you want to convert a negative remainder back to the positive remainder, Bhavya, you don't need to add the quotient, you add the divisor. You add the divisor. So let me show it to you using this. So 2 into 3 minus 1, right? This is what I had out here. Now if I add plus 2 and minus 2 here, okay, just because plus 2 minus 2 gives me 0. So if I do that, what you will notice is, and if I do some manipulation, so what I'm doing is, I'm writing 2 into 3 minus 2 together, and I'm writing minus 1 plus 2 separately. Just notice I just rearranged terms. This gives me 2 into 3 minus 1. So 2 into 3 minus 1 is nothing but 2 into 2, which I had before. And minus 1 plus 2 will give me the remainder. Okay, so this gives me 1. So this gives me back my original remainder. So the crux here is, you don't need to go through all these rearrangement. Please understand, this is just for your understanding, and you'll have the slide to understand it once again. All I'm trying to tell you is that there is a way to manipulate it, and once you manipulate it, you'll end up seeing that even if I have a negative remainder, the way to convert it back to a positive remainder is to add back the divisor. And the same is shown for the next question also. In this case also, if I add plus 3 minus 3, rearrange the terms, I'll end up with minus 1 plus 3, which gives me plus 2. So keep this in mind, even if you have a negative remainder, minus 1 to the power 49, you get minus 1. Okay, so to get back the positive remainder, just add back the divisor. In this case, I'm dividing it by 3, right? So I'll simply add plus 3 to minus 1 and get my remainder as 2. Is this clear, everyone? Kindly mark yes if this is clear. So the fundamental principle is very simple. Whenever I have an opportunity to write the number as a negative remainder, like minus 1 or plus 1, minus 1 mostly, and GMAT will not go beyond that, please keep this in mind. So whenever I have a situation like this, it is always good to write it as a minus 1, because especially when there's a big power involved in it, and then solve from there. So if I get minus 1 to the power something, so let me give you another example. Instead of dividing it by 3, if it was 8 divided by 8, okay? So if I'm dividing a number by 8 and I get my remainder as minus 1, what will I add back and get my answer? Minus 1, what will I add to minus 1? I'll add 8 to it, right? I'll add 8 to it and then simply say minus 1 plus 8 is 7. So my remainder is 7. Okay. So this is the main learning out here. Now keeping this in mind, which I've clearly highlighted here, so that you do not forget it. So to get back the positive remainder, simply add back the divisor. Now use this principle. Using this principle, try and solve this question. See if you can do it or not. Another 10 seconds, everyone. See, you can use the old method also. It's totally okay. Both these methods will give you the answer easily in this case. Okay, I'll end the poll in about 5 seconds. So if there's anyone who wants to mark the answer, please do it. Okay, great. So I'm ending the poll. About 80% of you think the answer should be D, which in this case is the correct answer, but I have a few of you think the answer should be C. And I guess I know where you went wrong. So let me ask you a few questions very quickly. What will be the remainder when 28 into 38 to the power 5 is divided by 3? What will be the remainder? This is something which we did a few minutes back. 0, right? So you could have very quickly said, okay, the remainder from this part is 0. So what you're left with is this. Now, once again, when 17 is divided by 3, what is the remainder? What is the remainder? 2. Okay. Now there are two ways to write it. Either you can write it as 2 or you can write it as minus 1. Both of these ways are possible. So either you write it 3 into 6 minus 1 or 3 into 5 plus 2. Both way will work. Okay. One quick way, one easy way I'll tell you is to understand whether you can write it as minus 1 or not is, always check the remainder out here, positive remainder. So say if the positive remainder is 1 less than the divisor, if the positive remainder is 1 less than the divisor, then that's a clear indication that this number can be expressed in the form of negative remainder. It can be expressed as something into minus 1. That is one quick way to make a decision. Okay, so instead of say 3, if you would have 7, and I would have got 3 into 5 plus 6, okay, 6 is 1 less than 7, then that would have been a clear indication, okay, I can write this as 3 into something minus 1. Sorry, 7 into something minus 1. Okay, just telling you this is one way to do it. Now, either of these cases are fine. Even if you take 2, it will be okay. You can take minus 1 also. In both these cases, what will happen is if you take it as minus 1, the easy part is you'll get minus 1 to the power 7. Now, those of you who marked the answer as C, did you write minus 1 to the power 7 simply as 1? Did you make this mistake? Kindly mark yes if you did so. Minus 1 to the power 7 as 1. Or did you solve 2 to the power 7 and then went ahead doing it? Okay, so you did that. Please note the power, or in case of minus 1, the power plays a big role. So if it's an odd power, minus 1 to the power 7 will give you minus 1. Okay. When minus 1 obviously is a negative remainder, you need to convert it back to the positive remainder. So to do that, what will I add, guys? What will I add here? I'll add back the divisor, and the divisor in this case is 3. So if I add that back, I'll get my answer as 2, and hence the answer in this case will be choice D. Now somebody is asking what if it was 19 to the power 7? If it was 19 to the power 7, then what will I get when 19 is divided by 3, everyone? What will I get when 19 is divided by 3? 1, right? Now what is 1 to the power 7? 1 to the power 7 is 1. So the answer in this case would be 1. That's it. The addition of the divisor is only done when the remainder is negative and you want to convert it to positive. If it isn't, if it is already positive and less than the divisor, then that will be your answer. That's it. Okay. Now let me tweak this a bit. I hope this is perfectly clear. So I've just changed a few things here. Now tell me what will be the answer. And once again, please take your time. Make sure that you get this one correct. After this, we'll be moving on to DS questions. Another 10 seconds. Okay, I'm ending the poll now, guys. Well, I'm glad to see the result. About 88% of you think the answer should be E, which is definitely the correct answer. Let me very quickly discuss this because most of you have got it correct. So in this case, everything remains the same. Even in this case, 24 to the power 3 into 38 to the power 5 by 6 will give you a remainder 0. Why? Because 24 is divisible by 6. So the remainder is 0. 0 into anything will give you 0. So the main thing, the main rule is of again 17 to the power 7 by 6. Now some of you might again use positive remainder, some of you might use negative remainder. But this is where it gets interesting. See, 5 to the power, it's always easy to solve minus 1 to the power 7 than 5 to the power 7. Okay. So if I take minus 1 to the power 7, I'll again get minus 1. But it's a glad thing one of you was about to mark this, but it's a good thing that you did not because the remainder cannot be negative. As I told you, GMAT will always ask you for a positive remainder or a zero remainder. So in this case, since a negative remainder, I'll add back 6. Once I add 6, I'll get the answer as 5. Hence the answer in this case will be option E. Okay, is this clear? Now somebody is asking, why do we need to take a negative remainder when we anyways get 5 after adding minus 1 to the divisor? Now Amit tell me this. Instead of 7, if I would have had a 8, would my answer would have been 5 also, or would the answer would be different? Instead of 5, let me ask this question to everyone. So it's not always necessary that you will get 5 always as the answer. Okay, it depends on the power. A lot of things is dependent on the power. So instead of 8, what will be the answer? If I had minus 1 to the power 8, will the answer be 5 or will the answer be 1? The answer will be 1, right? Because minus 1 to the power 8 would give me 1. Hence the remainder would be 1. Now I don't need to add back the divisor. So in this case the answer is not 5, it's 1. So depending on the power, if you get a negative power, negative remainder with an odd power, in that case you have to add back the divisor to get the answer as 5. It's not always necessary that the answer will be 5. Okay, I hope that clears your answer, clears your doubt. So with this, guys, we have completed PS questions and we have learned something new today, which is negative remainders. Please keep in mind it's okay to take negative remainders, but it's not necessary. If you're comfortable with it, you can do it. Once you know negative remainders, we can solve these questions in under a minute. A lot of you don't know negative remainders, who don't know will take about 2 minutes to solve 5 to the power 7 and get the answer. But keep this in mind, if you have a negative remainder, always convert it to positive by adding by the divisor. If it is not negative, please do not unnecessarily add the divisor to it. Let me be clear. I have seen people making this mistake. Don't do that. So for example, if you get minus 1 to the power 8 and solving it gives you 1, that is your answer. Done. So somebody is asking why should we take negative determinants? As I told you, it's always easy to solve minus 1 to the power something, say minus 1 to the power 100, then solving 5 to the power 100, right? So just to ease our calculation, we are taking negative remainders. With this, guys, let's move to data sufficiency questions. We have 3 questions on this, and we have about 15 minutes to discuss these 3 questions. So let's get going. Here's the first one. Another 10 seconds, everyone. Okay, I'm ending the poll now. Once again, I have a very interesting result, and this happens for this question always. There's a split between A and C, though most of you think the answer should be A, and some of you think the answer should be C. And this is the type of question that I was talking beforehand, where you need to have really good conceptual clarity to solve this question correctly. Now in this case, I have been asked what is the remainder when P is divided by M, and the only information given to me is that P is greater than 1. That's it. Okay. Now tell me, now when I'm dividing P by M, okay, when I'm dividing P is equal to M plus 1 by M, if I divide it by M, okay, what will I get as my remainder? What will my remainder if I divide this by M, this thing? Let me open the answer presenter's question. I know it's a variable. A lot of people will think, oh, it's a variable, so obviously the answer is not possible. But I did tell you that always try and, so in data sufficiency, your task should always be to try and see whether you can get the answer individually from the statements or not. If you can, then the answer should always be either A or B. You should only mark the answer as C when you cannot get the answer from the first statement. Now in this case, once again, forget the power for a moment and look at M plus 1 by M. Now when M is divided by M, now split it, because see, this is almost like the similar question where we did where I taught you 31 plus 43 by 7. I taught you that, right? Indeed, what did we do? We separately calculated the remainder of 31 and 47, right? In this case also we are going to do the same thing. We are going to split this. We are going to find out the remainder when M is divided by M. Now think about it in terms of number if you are not comfortable with variables. When 3 is divided by 3, when 5 is divided by 5, the remainder is 0, right? What is the remainder when 1 is divided by m? Obviously, when anything 1 divided by anything, be it 3, 4, 5, 6, 7, does not matter. The remainder will always be 1. So in short, you can say when m plus 1 is divided by m, the remainder is 1. If you bring back the power also, it does not matter because 1 to the power anything will give you 1. So the answer in this case is, since we want to find out the remainder, will be 1. And therefore, we can conclude that statement 1 is sufficient. Since statement 1 is sufficient, obviously you can confidently say if statement 1 is sufficient, the answer cannot be B, C or E. You can eliminate that. Now the only possible case is either the answer is A or D if you get answer from the second statement. But the second statement, just tell me m is equal to 8, nothing else. It is not giving me any information about P. I do not, from the question stem also, I do not have any information about P. So just using the question statement and statement 2, please keep in mind, don't involve statement 1 now because we are individually analyzing it. So if you do this, you can say that no information about P and hence statement 2 is not sufficient, hence the answer is A. Now somebody is asking 1 by m. Now that's what I'm asking. So for some of you it might be difficult to visualize what is 1 by m. But if I ask you, what is the remainder when 1 is divided by 7? What will be your answer? 1 divided by 7. Think it in terms of quotient, remainder and divisor. Think in terms of that. If it's difficult, I can write it and show it to you. So think it in terms of this, that 1 can be written as in terms of quotient, right? Is there any way, in any other way that we can write it? This is m. And this is QD plus R. Think about it. I hope you can see what I'm writing out here. I hope this is clear. Any other doubts? So Shreya, we are just ignoring the power. Just forget the power for a moment. Don't think about the power, okay? So it's the same way that we are solving questions. We are forgetting about the power. We are not worried about the power now. We are just looking at whatever there is inside the power, m plus 1. So focusing on m plus 1, I am dividing individually m by m and 1 by m. When m is divided by m, this portion m by m will give you a remainder of 0 because anything 3 divided by 3, 5 divided by 5, 4 divided by 4 is always divisible. So there is no remainder. But when 1 is divided by m, the remainder will always be 1 only. You cannot get anything else. That is why I am saying you are getting the remainder as 1. Now I told you to bring back the power again, right? So what was the power? The power is 8. So I am bringing back the power here and then saying 1 to the power 8 will always give me 1. Okay. Any other doubts, anyone? Let me bring the yes and no poll. That would be easy to visualize. Kindly mark yes if this is perfectly clear. If there are any doubts, please ask in the Q&A pod. So it's a bit difficult to view your queries in the answer presenters question. So if you have any doubts, please ask in the Q&A pod. I can see still a few of you saying you haven't understood. So please get this cleared. Please ask your questions in the Q&A pod so you understand whatever conceptual clarity you need, you get it from Ashutosh. Okay. With this, let's move to the next question, which is, okay, so the question again, as I told you, please ask these questions in the Q&A pod, but even if you infuse 8, you will have to solve m plus 1 to the power 8. Now tell me, can you solve m plus 1 to the power 8? Do you want to solve it? Do you know what will be the value of m plus 1 to the power 8? You don't, right? That is why we are ignoring the power. So everyone is asking the same question. Even Ritvik is asking, how did I write m plus 1 to the power 8 by m? So Ritvik, that is just a way of representing it for your convenience. So just forget for a moment, forget about the power. Think about it the way we solved the previous questions when we had 24 to the power something by 3. Were we worried about the power first? No, right? We were worried about what is the remainder when 24 is divided by 3. In the same way here also, when I'm asked this question, when I have m plus 1 to the power 8, think about it in this way. If this was 24 to the power 8, what would you have done? You would have simply taken 24, right? You would have solved 24 first and then bring back the power to see what can we do. Now, yes, you can use statement 2. But statement 1 alone is sufficient to get the answer. When I go to statement 2, I can see statement 2 is not necessary. Why will you need statement 2 when the answer you can get from statement 1 only? Why will you need m equal to 8? What do you need m equal to 8 for? When you know whatever be the value of n, the remainder will always be 1. Okay? With this, guys, let's move to the next question. Again, if you have doubts, please post in the Q&A pod. We are running short of time. We have 8 minutes and 2 more questions. So let's get to it. Another 10 seconds, everyone. I have very few responses this time, about 50 responses. Come on, guys. This is not that tough. Okay, I'm ending the poll now. And I have, once again, as expected, I have a split between A and D. Some of you think that the answer should be A, and a few of you think the answer should be 35% of you think the answer should be D. Now, think about in this way. Whenever you have a question in data sufficiency, there are two things which you need to keep in mind. One is obviously while solving these statements, you need to make sure that you analyze each statement first before combining them. The second thing is if there's a possibility of doing some pre-analysis, you should always do so before jumping to these statements. And that is one of the most important thing, which is pre-analysis. Because pre-analysis helps you understand what exactly do you need to find out. Now in this case, when I need to find out what is the remainder when 38 to the power n squared divided by 13, tell me, as I told you, we can ignore the power and then first of all figure out what is the remainder when 38 is divided by 13. Tell me what will I get my remainder as when 38 is divided by 13? What will be the remainder? Yes, I have got one correct answer, two correct answers, good. Yeah, a lot of you will think the answer is 12, a lot of you will say the answer is -1. This is exactly one of those questions where the negative remainder helps you a lot. If those of you got 12, you should have again thought, okay, I'm getting 12, which is 1 less than 13. That means I can write it as a negative remainder. So let me do so. 13 into 3 is 39. So I can write it as -1. Now, once I write it as -1 to the power n square, tell me, when will I get the remainder as 1? When can I get the remainder as 1? When can I get the remainder as 1? when n is even. Absolutely correct. But what will happen when n square is odd or n is odd? When n is odd, what will happen? What will be the remainder in that case? Yes, you'll get -1, but then you need to add 13 to it to get the remainder as 12. So this is the pre-analysis that I'm talking about, that you need to make these conclusions. That if n is even, I'll get my answer as 1. If n is odd, I'll get my answer as 12. So now, once you do these pre-analysis, you are very clear what you need to find out. So now the question becomes is, what you need to do is, while analyzing the statement, you need to figure out what is n. So did you notice we started from finding out what is the remainder, and doing the pre-analysis helped us understand that the only thing that we need to know to find the answer is the even odd nature of n. That's it. Okay. Now let's look at the first statement. The first statement is n leaves no remainder when divided by 24. If n when divided by 4. So when n leaves no remainder when divided by 4, what is the conclusion? N is a multiple of 4. If n is a multiple of 4, it is always even. Hence, if n is even, the remainder would be 1. Hence, statement 1 is sufficient. Okay. If I look at statement 2, statement 2 is root n is divisible by only 1 n itself. So what kind of a number is root n? It's a prime number, absolutely. So you need to be able to make such inferences that root n is a prime number, so n is a prime square. Now if n is a prime square, what will be n? Will it be even or will it be odd? N can be even, n can be odd. So n can be 2 also, n can be 3 also, n can be 5 also. So the answer in this case, if n is 2, the remainder would be 1. If n is 3, the remainder would be 12. But since I cannot say for certain what will be the remainder, that is why statement 2 is not sufficient to answer the question. Okay, I hope this is clear, and hence the answer is A. Now let me tell you a few important things which will help you ensure that you don't end up marking the wrong answer. Those of you, how many of you out here forgot about 2? Let me bring the yes and no poll. How many of you, while analyzing statement 2, did not consider 2 as a prime number? Kindly mark yes. How many of you did that? You did not consider 2. Now let me tell you one thing which will help you even ensure or make you think twice before marking the answer as D. Those of you by mistake also, say forgot about 2. You only thought, okay, n can be 3 or 5 or 7, or n can be only odd. Now if n is odd, if n would have been only odd, what would have been your answer? The answer would have been 12, right? Those of you thought about prime. Now, if you did not, then obviously there's a problem with your inference. You need to learn how to infer these things, because if you cannot learn how these inferences are done, you'll make a mistake. Okay. Now, some of you are saying the answer would be 12. So from statement 1, you are getting the answer as 1, the remainder as 1, right? From statement 2, you are getting the answer as 12. Now keep this in mind. In data sufficiency, the answer can, if you are getting the answer from both these statements, if you are getting it, then the answer needs to be the same. It has to be the same. You cannot get two different answers from two different statements. So if I'm getting the remainder as 1 from statement 1, if statement 2 would have been sufficient, please focus on this, would have been sufficient, if, then in that case the answer from this statement also would also come as 1 only, nothing else. So if some of you made the mistake of thinking this as odd and thinking the remainder can be 12, you should have questioned yourself, okay, I'm getting two different answers from both these statements. That cannot be right, because in GMAT does it from data sufficiency, I get the same answer from both these statements. Okay, so there are two mistakes some of you made. One of you, if you could not infer this is prime, you would have faltered. If you thought about prime numbers, prime square, and did not think about even numbers, that is another place where you would have faltered. Okay. And another thing is some of you saying a to the power n to the power n. No. So a to the power n to the power n is a to the power mn. That is correct. But this is not a to the power n, a to the power n to the power n. This is a, and this is n to the power m. What you have written out here is am into n. These are two different things. These are two different things, Shreya. I hope this is clear. A to the power m into n, a to the power m to the power n are two different things. A lot of people I can see are talking about this only. Please, Projoy also is saying the same thing. I can see a lot of you thinking the same thing. No, please don't do that. This is wrong. This is wrong. This is not 38 to the power 2n. This is 38 to the power n square. Okay, n into n. It's not 2 into n. The bracket has been put in properly. If this would have been 38 n bracket 2, then this would have been 38 to the power 2n. So those of you who are thinking 2 into n, you are not understanding the powers properly. So you need to go and look at the exponent concept file. I hope this clears the majority of the doubts. I can understand where this mistake came from. Okay. N square is not equal to 2n. N square is equal to n square. N into n gives you n square. N into n does not give you 2 into n. Think about it. 5 into 5 will give you 5 square, 25. 5 into 5 does not give you 2 into 5, 10. So I hope you understand this difference. 5 square is 25. 5 square is not 2 into 5, 10. Okay. Now let's move to the last question, everyone. If you still have doubts, please ask in the Q&A pod. Let's finish the last one. Another 10 seconds, everyone. Okay, I'll end the poll now. Those of you who want to put in your answer, please do so. Okay. Fine. Some of you think the answer should be D, and I have about a few of you, 23% of you think the answer should be A, and some of you, around 10% you think the answer should be B. Now see, these are questions, as I told you, see again, these are also based on the same fundamental principle, but now since we are dealing with variables, it gets a bit tough, right? So let me explain this question. So there's a solution out here which we can discuss, but let me ask you a few questions to help you solve this question very quickly. We need to find out what is the remainder when 4m is divided by 16. Okay. Now tell me, one way to write it is 4m is equal to 16q plus r, and I need to find out the remainder, where the remainder has to be obviously greater than or equal to 0 and less than or equal to 15. Okay. Now tell me, if when will be the remainder 0? Just asking. Though I know we need to find out the remainder in this case, but tell me, if when, in which case will 4m by 16 will give me a remainder 0? When m is what? When only m is equal to 4, or in other, when m is equal to 4k, or m is a multiple of 4, right? Is this perfectly clear? Okay. If m is not a multiple of 4, then obviously we'll get some remainder. These are the two inferences that you should be able to make. That okay, I'm dividing 4m by 16, I already have a 4 here. So if I get another 4 in m, that will be enough. M should be a multiple of 4, basically 4, 8, 12, 16. Then the remainder would be 0. If m is not a multiple of 4, then in that case, obviously we'll get some remainder, and then I need to process and find out what the remainder is. Now what I'm given out here is that m is equal, when m is divided by 4, m leaves the remainder of 4 when divided by 32 to the power 32. So m can be written as 32 to the power 32k plus 4. Now tell me, what is m? Is m a multiple of 4? Is m a multiple of 4? Yes, no? No? Think about it. If I divide m by 4, this by 4, what will be the remainder when 32 to the power 32k is divided by 4? 32 by 32k is divided by 4, what will be the remainder? The remainder will be 0, right? This is especially for people who are saying the answer is no. I'm asking them. Those of you are saying yes, absolutely, I'm sure you understand this. The remainder is 0. When 4 is divided by 4, what is the remainder? When 4 is divided by 4, the remainder is 0 once again. So when m is equal to 32 to the power 32k plus 4 is divided by 4, the remainder is 0. If the remainder is 0, then that definitely means that m is a multiple of 4. The other way to think about it, you can take 4 common from both of them, right? You can take common from 4 from here, you can take 4 common from here, and you can say that m is a multiple of 4. So if m is a multiple of 4, 4m will be a multiple of what? 4m will be a multiple of 4m will be a multiple of 16. And if 4m is a multiple of 16, then in that case the remainder will be 0. Tell me, is this clear or not? Kindly mark yes if this is clear. I can see a lot of you are saying no. So let me explain it in a different way. I hope this makes you understand this. So I have got m is equal to 32 to the power 32k plus 4. What I need to find out is 4m divided by 16. So let's multiply m by 4, because I need 4m. So if I multiply by 4 both sides, I'll get this. 4m is equal to 4 into 32 to the power 32k plus 4. Now manipulate it. Now write 30. Now multiply 4 both sides. So you'll get 4 into 4 here, which is 16. Now this 32 to the power 32 can be written as 32 into 32 to the power 31. I can break it down. The reason I'm doing this is because I can take 16 common, because this is 16 into something and this is already 16. So 4m is nothing but 16p plus 16. Now what will, this is nothing but 16 into p plus 1, which means 4m is a multiple of 16. If 4m is a multiple of 16, then in that case the remainder will be 0, and hence statement 1 is sufficient. If there is a remainder, obviously it will mean that if there was a remainder, that means not a multiple. That's correct, Anthony. If there was a remainder, then obviously that would mean it's not a multiple, but I will not get a remainder because I already have a multiple. I have 16 into something. I did tell you in the few questions back that when dividing by 16 into something, when 16 into something is divided by 16, the remainder will be 0, because 16 into something is a multiple of 16. Guys, any other doubt? Please ask. See, you can write 32 to the power 32 as 2 to the power 160, but what will you do next? Even after writing 2 to the power 160, you will have to take 16 common out, right? Because that is what you are dividing it by. So you can manipulate it whatever you want to, but at the end what you need to prove is that 4m is a multiple of 16. I hope this helps. Now the second statement is m cube is divisible by 16. Okay, so I hope statement 1 is clear. I've explained it in two different ways. It's totally up to you which one you want to use. One way to think about is m is a multiple of 4. The other way to think about is find about 4m. Now in the second statement I have m cube is divisible by 16. Now I have an explanation here which I'm going to show, but let me ask you a question just to make sure that if you understand it clearly or not. If m cube is divisible by 16, how many 2's does m have? How many 2's does m have? M cube is divisible by 16 means m cube has 16. But if m cube has 16, can m be a multiple of only 2? If m is say 6, is it possible that m cube will be divisible by 16? Or say if m is only 2, let me